So next we have Natalie, who is the founder of enbee Architecture Design. She designs home renovation projects to make them beautiful, healthy, and warm. She's driven to demonstrate what is possible, to build better and inspire change. She explores and inputs into practice, innovative ideas, and solutions. She focuses on retrofitting older properties and uses a palette of low-carbon, natural materials to reduce the energy loss of buildings, create healthy indoor environments, and minimize the impact of the building work. So Natalie is going to speak to us specifically about retrofitting period property. So thank you so much, Natalie.
Thank you. Having seen the other two presentations, I'm slightly wishing I'd put some more pretty pictures. But mostly I'm going to be showing you a little why I'm here and the sort of big picture in the world and why it's important, the materials that we choose, and our focus on some how-tos, and specifically look at some walls and some windows and how we tackle that. And then at the end there's just a few small pictures of some finished work. So basically what I've just said, why take this route, why my role is important, why materials matter, some tips on insulating your home, and some results on one of my projects. Now if you're considering a retrofit yourself, I've got an online assessment, I've got some cards there with that, and you're very welcome to try out the online assessment. This is about me. This is me about 2015. I was still like this. I had not taken any attention to the climate emergency, and next slide. I sort of woke up at that point. Next slide. And it kind of felt like a really massive challenge. I don't know if any of you see it like that, but it's like we have to push this boulder up a hill, and it's this massive challenge. Next slide, please. So I was like, what can I do? You know? And I came across something called Project Drawdown. It's an analysis. It's like the biggest study of 100 different ways that you can reduce how the world can reverse climate change. And I discovered that loads of the things you could do are in the building sector. So how much do our buildings emit? Well, the UK is responsible for 40% carbon emissions. 40% of the carbon emissions from the UK are from buildings, from building work and from heating them. And 35% of that is we use 35% of all the energy, and 20% of the carbon is from heating. 20% of the carbon comes from our homes, from heating them. And we've got to reduce it massively by 2050. I'm a pragmatic optimist, I've discovered. And so this is how it basically breaks down across the world. 28% is on powering our buildings, and 11% is to do with the materials that we use to build it. And that's why everyone here talking so far has been talking about natural materials. And 80% of our buildings are already standing. And that's why retrofit's really important, because most of the effect we can have is on existing buildings. And then there's various bodies like LETI who've done loads of studies into what we can do, what targets we need to make to get there. Next slide, please. And so they've got things like the average UK home, how much it emits, how much power does it need, how much it emits, and the average energy bills. It's probably higher than that now. And then where we need to get to. And the RIBA has done it as well, so they've got their targets for the heating part, the operational side, which means they've said we need to reduce by 60% by 2030, which is a massive ambition. And in terms of the building work, it's a 40% reduction in how we do it. So the whole industry is working at that now. We're furiously trying to work out how we're going to get there. So that's why my role is important. And why materials matter. And when I come to designing a building, I've got to choose the materials that go into it all. in the retrofit. So there's usually, in my work, it's a combination of extensions and retrofit. And I could choose materials right at the top. Aluminium, right at the top. What's next? Galvanised steel, copper sheet, zinc, structural steel. All the regular insulations are around here. The materials that we're talking about today are all here at the bottom. And that's why they're so important, because they have the lowest carbon. Next slide, please. So you can build a building different ways. This is the old school way. Well, in the 20th century and early this century. If you go further back, it's more like that. And now we're all trying to push our buildings towards this picture, where we're reducing the carbon as much as possible and putting materials in that draw carbon from the atmosphere while they're growing, and then you lock that carbon into the building. Next slide, please. So that's what this is about. Growing takes carbon in, regular materials, they're all above the line, and if you have low carbon materials, you're starting below the line. So even though you might all the harvesting, manufacturing stuff, it starts from a lower position because of that being a low carbon material. Here's some of them. There's some more at the back along the tables there. So we can change and pivot the way we work to make it a positive thing. Instead of taxing the environment, we can change the whole picture. So how about your homes? Who here lives in a period property? Most people. Is it hard to heat? Yeah. How cold is it? How cold does it go? I've been to houses at 12 degrees. That's pretty cold. I have to keep my coat on. Below 16? Yeah. If we took a thermal image of your house, which one do you think it would be? This one. Yeah, leaking heat. Next slide. Like that. It's like a leaky bucket while being freezing. All the heat pouring out of your building. At the same time, bills going up massively. So now I'm going to just look at how you, just a bit about some detail about insulating a building. So an existing brick wall might have a U value of about 2. And then you can take it down to 0.3, that's with internal insulation. Or if you go as far as, or if you're building something new, you might take it to 0.15, 0.16, or lower. So Passivhaus starts at about 0.15. So this is a wall that we retrofitted. The existing wall here. This is very conveniently in a doorway, so we've managed to get this cross section. We lined the wall. We had to take the plaster off, and then we straightened up the wall with a lime plaster. Then we put something called diathanite, which is a lime cork mix. Then there's 80 ml of wood fibre, and then there's some lime plaster on the top, but it's not here yet in this image. And so this is a bit of a how-to. So you might start with a wall like this, which is a mix, might have wallpaper on it, and it's got a mix of old plasters and new plasters, and so it's a bit of a mess. Next page. Or it might have bits falling apart, or mould in it, or some water damage. Next slide, please. And then, so this particular house, we had to take take it back to the brick. And this is like a forgotten area, which is very easy to forget corners, because there's so many junctions. You might think you've dealt with the whole external wall, but in this location, there's a front doors somewhere around here, so you have to insulate along here to make sure you've dealt with the wall that's coming up to the doorway. And this is another area where people don't think about doing so. They think, okay, I've got to make that external wall insulated. They don't think about oh, I need to go through the floor zone, especially the regular builders, they just want to stop just here to think it's done. But you really need to take it through the floor and deal with that section as well. And if you're putting a new floor in, for us, we put it on compact foam pads in order to not put it in, take the structure through the insulation zone. Next slide. So this is the diathanite that I mentioned earlier. They've got these little markers to get it exactly the right depth. So they were able to skim and reach that, the right depth. Next slide, please. And then when you put things like the power sockets in, there's a potential that you might get an air leakage in. So we put in various tapes to stop the air leaking. And if you're doing the whole house, you can end up with a lot of insulation going in. So this is my client very proudly standing in front of all the insulation that he's about to put in. Next slide, please. And how it goes on. So you've got the diathanite behind, and then you basically put it on like tiling. And then this bit is a new build bit. So we've got it full filled with flexible wood fibre. Then we've got this material called compact foam, which is structural, but it's insulating, and so we can fix the windows into that. This is some flexible wood fibre. You can see here we've got the timber frame full filled with flexible wood fibre, and then the solid board on the top. And then for air tightness, we use OSB, which is this material here, and then we tape it all up with these blue tapes. And this particular contractor was excellent at making sure things were airtight, so he was going around every single screw hole has got a bit of tape on. Next slide. That's me telling people about it. Windows. You might start with old leaky windows can have a U value of 5 to 7, and they can be taken down triple glazed, 0.85 to 1, or lower now. They're constantly improving that. And so these are some of our windows going in. And often people put windows in with spray foam. Problem with spray foam is it gets solid, it fills the gap, it's great, it expands into the gap, but it gets solid, and then if there's any movement, then there's a gap again. So this material here is a material which is it's a memory foam. It's a bit like a mattress that you might sleep on camping, and it just expands into the space, but if there's any movement, it just moves with it. And then we tape the windows into, we make sure everything's airtight by taping everything. And there's me showing more people around our project. And you can see we had these triple glazed windows, and a nice way to see that it's really airtight is that it has got 2 seals on it to really make sure that the air isn't coming through. So I've had triple glazing in the house where I put my kids' drawings next to the window, and then when it was windy, you could see the drawings flapping about. One thing that you have to be really careful with retrofitting is the structural components like steel, which will often be sitting in the outer envelope of the building, which you're then trying to insulate from the inside warm bit, and it's going right through the insulation. And you have to try and deal with that so it doesn't bring the cold in. Especially since it's a conductive material, it's really easy to get it in. So we sometimes wrap it in something called aerogel, which is this, used sparingly because it's very, very expensive. And when we work out all our build-ups, I kind of see our wall build-ups as being a bit like a recipe. And I give the contractor this recipe and a how-to guide. Or it's like the recipe and then the method of putting it all together. And when I'm devising them, I run things through a calculator to make sure that we reach the U value and we reach all sorts of other things. So this will tell me if it's too wet. If you go to the next slide, this you can see it's starting to show moisture in the build-up. And yeah, so that will start to tell me I need to be a bit more careful about how I'm applying the materials. So I'm just going to touch on this project. It started as a rep. We did lots of work for a year and a half, and then it ended up rather beautiful, which was nice. We had a heat demand of 650 kilowatt hours per metre square per year. We used the Passivhaus planning package to work out how we were going to reduce that. We took it from 650 down to, in fact, we got to our measured results are 33 kilowatt hours per metre square per year. And this sort of gives you the sort of average figures. Passivhaus down at 15, so we didn't quite get to Passivhaus, but we were pretty close. Enbee 25, which you saw earlier. So a 92% recorded energy efficiency gain. An image of it before, same window afterwards. Very nice to have another architect visit and post this little comment, which I then have used in my slides ever since. So you've got the 60%, I've talked about the 60% reduction in energy consumption and 60% reduction in materials. When we analysed that project, we found that we had already met the 2030 targets. So whilst it's, I didn't even know that we'd done it until I put that project in for an award, and I went along to find out if we'd won. We didn't win, but I found out that we'd also hit the 2030 targets that day. So I was so excited about that, didn't matter that. So we met the 2030 targets, there we go, and a few pictures of the inside. So design and performance, really, really important for us, as it is for everyone here. And then what I've been doing since, which is to talk about the project. It's really important to get the word out, get people knowing about what's possible. Next slide. So I've got a challenge for all of you. So then remember the boulder. We're all pushing at the boulder. Everyone here is pushing at that boulder, and I'm hoping that you will join us in pushing at that boulder, because we need all of us. And just one more slide, I think, because we want adoption to be mass adoption. We want everyone to start seeing their neighbours doing something and think, oh, I should do that too. Thank you very much.